Fighter jets play a vital role in establishing air superiority in military conflicts. These aircraft are designed primarily for air-to-air combat, enabling them to be menacing and dominate the airspace above battlefields. Bombers and attack aircraft are used to engage with adversaries effectively. The key feature of a fighter jet includes its high speed, maneuverability, and immense firepower. However, despite the aircraft being versatile, the success of gaining air superiority depends on other factors as well. These factors include pilot skill, strategic approach, the performance of the fighters deployed, etc. Fighter jets have undergone significant evolution over time, progressing through distinct generations marked by technological advancements. The earliest jet fighters emerged during and after World War II, characterized by straight wings and basic construction materials like wood or light alloys, forming the first-generation jet fighters. These aircraft lacked advanced avionics and were primarily focused on air-to-air combat. However, subsequent generations saw substantial technological leaps. The fourth generation introduced maneuverability, fly-by-wire systems, composite materials, synthetic radar, and infrared capabilities, enhancing aerodynamics and stealth. Modern fighter jets are also equipped with capabilities like ground attack as well. Developing technologically advanced and superior fighters and maintaining a strong flight fleet consumes a significant portion of the budget, as throughout history, fighter jets have evolved from early biplanes to advanced aircraft powered by jet engines, with innovations like ejection seats and all-moving tailplanes being widespread. One of the most recognizable and most powerful jets used by the Navy is the F-22 Raptor. When the U.S. Navy revealed the F-22 Raptor, it was the most advanced piece of avionic technology at the time, and it had zero competition showing since it took its first flight in 1987. However, it wasn't until 2023 that the F-22 Raptor recorded its first air-to-air kill, where she hunted and shot down a Chinese spy balloon off the coast of South Carolina. This aircraft had so much potential for damage and destruction that the United States never approved of selling it to any other countries, not even to its closest allies. This goes to show how amazing of an aircraft the F-22 is. And though it wasn't until recently that it recorded its first air-to-air kill, it's been used extensively in various operations across the world, mostly in a reconnaissance role as well as a ground assault capability. This jet boasts a long list of capabilities. It's ultra-maneuverable, and at the same time, it has greater stealth capabilities than even the F-117 Nighthawk. But why does the aircraft have a golden canopy? How can thrust vectoring technology make the F-22 more stealthy? And why does the United States government have a ban on exports of the Raptor while it exports the F-35 openly? Although the F-35 is more advanced than the F-22 in some ways, why does the United States not export the F-22, despite it being one of the greatest fighter jets of all time? The truth behind why the manufacturing and production of the F-22 has been put to a stop is far from what you would imagine. The Raptor has three main key areas that make it unique: its stealth, advanced avionics, and speed and maneuverability capabilities. The F-22 is the first American fighter aircraft that can fly at supersonic speeds. In early test flights, it sustained speeds of Mach 1.5, 1.5 times more than the speed of sound. Not only that, it's the first American fighter jet that can supercruise, meaning that it can maintain its speeds above Mach 1 without the use of its afterburner. This is significant, as not only does it reduce its radar cross-section, it eliminates extensive infrared readings, and it helps it maintain extensive periods of combat duration. Before the F-22, all fighter jets could only cruise at speeds under Mach 0.9 while carrying a normal weapon load. These fighter jets also could fly supersonic, but only after using their afterburners. Now, as we know, the F-22 is an aircraft designed for stealth, so using the afterburners is not ideal. The afterburner plume reflects radar signals, creating a significant infrared signature, and for aircraft that are meant to be stealthy like the F-22, It's a big, fat no-no. The Raptor can perform maneuvers like the J-turn and Cobra with ease. These maneuvers allow the aircraft to evade homing missiles launched by enemy air defenses and fighters. However, it's very unlikely for the F-22 pilot to find themselves in such a dangerous situation, as the Raptor is so stealthy and quick that it can become invisible for enemies to even find it. When it comes to stealth, the designers already have a lot of experience. Since the 80s, Lockheed has already been holding different experiments with stealth in the F-117 Nighthawk platform. At that time, the understanding of stealth was only based on the theory that sharply angled panels could disrupt and deflect radio waves, resulting in an inaccurate signal picture for the observers at the radar station. However, stealth technology is not just one technology. It's a set of different pieces of tech combined to drastically reduce the distances at which a vehicle can be detected by enemies. It involves lowering acoustic sound profiles, as well as thermal energy readings as well as other aspects. In the late 1980s, various materials that were able to absorb radar became available to U.S. defense contractors. This meant that stealth aircraft, such as the B-2 and later the F-22, could have more aerodynamic, curved surfaces for less drag and better maneuverability and operational range. On the other hand, electric vertical takeoff and landing, or eVTOL aircraft, are being explored by the U.S. Armed Forces for a variety of potential uses. These aircraft take off and land vertically, like helicopters, and the use of electric motors makes them quieter and more environmentally friendly. Because nothing says environmentally friendly more than a weapon of death and destruction dropping bombs and firing missiles. But here in America, we're here to destroy our enemies, not the environment. And that's a check you can take all the way to the bank. Electric plane engines function by utilizing electric motors that are powered by batteries and cause zero emissions of any sort. They have lower operating costs and also require minimal amounts of fuel. Many of these engines are also hybrid, which combine the original jet engine with the newer electrical systems. And when talking about electric aircraft, the idea may seem like it's futuristic. However, like electric cars and bikes, the concept has its roots dating back much further than many would think. Electric aircraft are much more energy efficient compared to traditional helicopters. These aircraft are suitable for logistical operations as they don't require a lot of time to spin up like traditional aircraft and can go from one point to another in a matter of minutes. The design of these electric aircraft provides a significant advantage in flexibility, allowing for many new technologies and innovative configurations to be installed in order to meet the requirements of the military. Rolls-Royce is one of the pioneers behind this technology. The British engineering company is infamous primarily for its high-end power systems and engines. In 2021, the company revealed the Excel model, which translates to accelerating the electrification of flight, officially known as the spirit of innovation. The small-sized aircraft showcases significant developments in the field of electrical aviation. Rolls-Royce has shown that its aim is not only to demonstrate the environmental benefits of electronic propulsion, but also its performance capabilities as well. The spirit of innovation was given the task of setting a new world speed record for electric engine flight. In 2021, the plane reached a maximum speed of 386 miles per hour and also sustained a speed of 348 miles per hour for a distance of about 3,000 feet. This enabled it to earn itself a place in the Guinness Book of World Records. However, despite the aircraft being impressive, it doesn't have a lot of potential for the military as of yet. However, the United States Air Force has recently introduced its first all-electric aircraft, known as the Beta Elia. Beta is an American aerospace manufacturing company that specializes in electric vertical takeoff and landing concepts. The most impressive model that they've made is their Elia 250. It's a unique civilian plane with 4 top-facing lift rotors and a rear propulsion rotor system. The intelligent, stripped-down aircraft is capable of traveling approximately 250 nautical miles on an hour of charge. The aircraft also has the capacity to accommodate 6 passengers and carry loads of up to 6,000 pounds while traveling at a speed of 168 miles per hour. Though it may take some time before the U.S. military has electric bombers and fighter aircraft, it utilizes modern electric technology as often as humanly possible. Many air bases now feature remote-controlled all-electric airplane tugs. These powerful devices come with the potential to significantly cut down on manpower and fuel usage by helping to tow planes around hangars and taxi areas. The best part about them is that they're much more compact than traditional gas-powered tugs. Beta Technologies, the creator of the A250, has recently emerged as a global leader in electric-powered aerospace technologies. The company is one of the few others that have been awarded a contract by the United States Air Force and introduced new vehicle and airborne concepts for a wide range of additional purposes. Electric propulsion is the main focus of Beta's approach and aligns with the aviation industry's turn toward more sustainable and environmentally friendly technologies. Electric vertical takeoff and landing technology has been growing significantly in recent years. One of the vehicles most likely to see this type of use is the Hexa aircraft from Lyft. Its unique design resembles a large drone rather than a traditional aircraft, and it's specially designed to be easy to fly. While it can be piloted manually, the Hexa is primarily designed for autonomous flight. Its 18 electric rotors allow it to take off and land smoothly while moving through the air upright with minimum G-forces applied to the occupant. The Hexa is aimed at the recreational market rather than commercial urban air mobility. However, the United States military has expressed a lot of interest in the aircraft due to its potential for silent, rapid movement of personnel and equipment. These aircraft can be used for a wide range of military applications, including reconnaissance, transportation, and logistics. Additionally, the high-speed and long-range capabilities of some eVTOL designs make them suitable for the rapid deployment of troops and equipment in remote or difficult-to-access locations. There are also potential applications in search and rescue missions as well as medical evacuations. The main focus of the eVTOL industry is the civilian marketplace. People of all backgrounds have discussed the potential for flying cars, and while the vision of what these vehicles might look like has changed over the years, eVTOL aircraft are proving to be the most likely candidates. One of the companies at the forefront of this movement is Joby Aviation. Like Lyft, it's also particularly well known for its work in the eVTOL sector. It was founded in 2009 and immediately went to work on the concept of urban air mobility, which had the primary aim of providing fast, efficient, and sustainable air transportation for populated urban environments. Joby's S4 is reported to have a range of up to 150 miles on a single charge with a top speed of around 200 miles per hour. It's designed to carry 4 passengers as well as a pilot. The S4 is easy to fly and offers uninterrupted safety. While traveling to and from work in an electric aircraft may seem like a distant dream to many people, Joby Aviation has different opinions. The company has already initiated the production of its first few production-conforming aircraft at its pilot facility in California. The Marina facility, capable of manufacturing dozens of aircraft per year, is completely state-of-the-art, using everything from 3D printing technology to automated assembly lines to produce various parts and components for the aircraft. The company recently announced the development of its first large-scale eVTOL aircraft production facility in Dayton, Ohio. The facility will be located at Dayton International Airport and cover over 140 acres with a cost of up to $500 million. Joby is confident that their technology will be adopted on a wide scale very soon. The company claims that their creation will be significantly quieter than helicopters and much more affordable as well. The founder and CEO of Joby Aviation, JoBen Bevert, stated to the Washington Post in 2021 that the company is soon planning to begin its service at an average price of $3 per mile and then eventually move that down to below $1. Both public and private organizations have shown deep interest in what Joby Aviation is planned on doing. Even NASA invited its company to bring its prototype to its Advanced Air Mobility National Campaign event in 2021. During this event, more than 50 microphones were used by a series of teams to investigate and determine just how loud or quiet the company's aircraft was. The way Joby sees it, this would likely play a big role in how well the public would adapt to the idea of urban air mobility. During the test, the microphones analyzed Joby's eVTOL during takeoff, hover, and overhead flight. Joby has invested millions of dollars into making sure their new aircraft would be flyable by pilots and non-pilots alike. Joby also designed a comprehensive simulator with the help of aviation experts. The aircraft has a unified control design that doesn't require the use of both hands and feet like a helicopter. They've also managed to incorporate a wide degree of shortcuts into the controls, making flying and handling a safe, secure, and easier process. The quieter operations of the eVTOLs result in reduced acoustic signatures, hence making them hard to detect during missions. Acknowledging the versatility of electric aircraft, it's fair to say that they could become a very valuable asset for the military in the future for various roles, including reconnaissance. And that brings us to the end of the video. We hope you enjoyed it, so make sure you show your support by liking the video and subscribing to the channel. And don't forget to click that notification bell so you're updated as soon as we release new content. Thanks for watching, everybody. We'll see you in our next video.